All right, we're back, and we're gonna talk about the kinematic equations. We're gonna be using these a lot, especially for motion in 1, 2, and 3 dimensions. Of course, we're gonna start with motion in 1 dimension and work our way up. These 4 equations were specifically derived and chosen for a reason that we discussed in the last video. So remember, we're looking at kind of 3 different orders of motion. We're looking at displacement, velocity, and acceleration. Now, as we discussed in the last video, there are higher orders like jerk and joust, and it just keeps going. There's a whole list of them. But because of the most common thing that we find in our natural world is constant acceleration. Reason being is because gravity, electromagnetism, most of the natural forces are actually constant acceleration forces. And so looking at the natural world from a physics perspective means that we're going to be looking at constant acceleration a lot. Now, we may build a device that has jerk or joust or higher orders of motion, but in the natural world, it's very rare to see that kind of motion. So these 4 equations work for constant acceleration, which is the highest order of motion that we will work with in this course, and so that's why they were specifically chosen. Now, they may look kind of intimidating, but once you start to use them, you'll get an intuition for what equation to use for what kind of purpose. One really important thing to look at when choosing an equation to use is how many knowns and unknowns are there, right? So, for example, let's say that I gave you a value for acceleration, I gave you a value for v initial, I gave you a value for time, and the question was curious what the final was. Well, we would take a look. So these were all given. Let's just give some numbers to them anyways. So let's say acceleration was 2 meters per second squared. The initial was 0 meters per second. It started at rest, is how you'll commonly hear that in a problem. And let's say we knew it took 2 seconds. All right, so we would look up here and let's look at this one. We have the initial. We don't have the final, so that's one unknown. We do have t, so that's another known, but we don't have x. We don't have our displacement. So here what we're looking at with this equation is we have 2 knowns and 2 unknowns. We should probably skip that equation because we're going to need to find another equation to use in tandem with that equation to solve the problem. Because of the fact that whatever number of unknowns you have represents how many equations you need in order to solve a problem if it has a solution. So because we have 2 unknowns in this equation, we would need to find at least one more equation to solve for the final. So let's go ahead and take a look up at this one. Well, we have time. Time shows up a lot in this equation, right? Twice. So there's one known. Let's go ahead and start marking these down. So here we decided there was 2 knowns and 2 unknowns. And here we've started with 1 known, which is time. Look, the initial's in here as well. That's 2 knowns. Hey, acceleration is in here as well. That's 3 knowns. So we've got up to 3 knowns, which is really great, except for the fact that you'll notice something. V final, which is what we're looking for, is nowhere in this equation. So the one thing that we're actually looking for with these values that were given to us does not exist in that equation. And so for that reason, it doesn't really matter how many knowns you have because the equation does not include what we need to solve for. So both of these are we're throwing them out. Let's go ahead and look up here. So acceleration, that's 1 known. V initial, that's 2 knowns. There's no t in this equation, and there is a v final, so we've got what we're looking for. But when we look here, we don't have our delta x, or our total displacement. We don't know that. That wasn't given to us, so that's 2 knowns, 2 unknowns. So 2 knowns, 2 unknowns. And so for that reason, we're going to go ahead and call it quits on that equation as well, because we would need to find another equation. Because there's 2 unknowns, we would need 2 equations if a solution existed. And now, finally, the one that I just kind of wrote these numbers out for, I wanted to work through them backwards so you could see why not to use the other ones. Now that we're here, we're going to look and we're going to go acceleration, acceleration. We've got 1 known. Time, time. We've got 2 knowns. V initial, we got 3 knowns. And V final's in our equation, so we only have 1 known. I'm sorry, we only have 1 unknown. So we have 3 knowns, 1 unknown. And that 1 unknown means that if there is a solution, that we can solve it just with this equation. So let's go ahead and do that. So this is pretty much just plug and chug at this point. We've figured out what equation we want to use, and now we're going to plug in our values. So acceleration, 2 meters per second squared, times time, which is 2 seconds, 2 seconds, plus the initial, which is 0 meters per second, 0 meters per second, equals V final. And V final is what we're solving for. So I wanted to add in the units here. Once you get a feel for these equations, you'll probably just ignore the units and trust the math. But for now, I wanted to kind of show you how to use a little bit of dimensional analysis, which can really save you when you're confused about a certain equation. So here we have 2 seconds. Here we have meters per second squared. Well, if we take 2 times 2, we get 4. And then we multiply the units, that's meters seconds per second squared plus 0 meters per second equals VF, V final, velocity final. So you'll notice that the seconds can cancel with the seconds. Seconds divided by seconds squared is going to give us meters per second. We're canceling out the seconds. And what we end up with is, look, meters per second plus meters per second. 4 plus 0 is 4 meters per second, and that's V final. And this is a good indicator that we did everything right? Because we know that velocity's units are meters per second. And so if we ended up with meters per second as a solution, that's a good thing. And keep in mind that you can only add numbers that have the same units, right? You can multiply numbers that have different units, but you have to add numbers that have the same units. You can't add numbers that have different units. And so this just shows us that dimensional analysis can help us be confident in our solution. And so that is just some example of a problem that once we found the equation we needed, it was just a one-step process. So anyways, I hope this video was helpful in gaining a little bit of intuition towards when to use what equation. And then for the next several videos, we're going to go through a problem that's going to deal with one, we're going to have one problem per equation we have. And then I'm going to do a couple of videos, maybe videos where we have to use 2 equations. And so, yeah, have a good day, and I'll see you next video.